So let's isolate one of the cubes. And I want you to look at the most essential aspect of understanding perspective when you're doing freehand drawing. We did not do freehand drawing here. We used a ruler, and we used very specific rules to create very specific measurements. In freehand drawing, ideally you don't use a ruler, but if you understand some key elements of the behavior of the way objects look in space as things get further away from you, then it helps your freehand drawing accuracy. Okay, so this is a cube, and we know from previous lessons that the cube has 6 planes, and each plane, if you're looking at the plane square on, it's going to be a square, right? So we're looking at this top plane as a square in perspective. We're looking at this side plane as a square in perspective. Now notice this. I'm using my pencil as a gauge to measure the distance of the top corner on the left to the top corner on the right. Okay, so I'm putting my tip at the top corner, and I'm putting my thumb to mark off where the right corner ends. I'm going to compare that distance to the back edge. Do you see the difference, right? So this back edge distance is shorter than the front edge distance. And that's going to be the case with every single one of these squares. Okay, so what that's telling you is that the back plane, which is also a square, let me go ahead and draw in the back plane. So the back plane, which is also a square, back here, is smaller than the front plane. The front plane is closer to you. So the front square plane is closer to you, so it's going to be bigger than the back square plane, which is further away. It's not that much further away, but it doesn't matter. Anything that's even a little bit further away, that's the same shape, is going to be smaller than the one that's closer to you. And that applies to every single one of these cubes. Don't get confused. All I did was take the vertex that I hadn't drawn a converging line with to the vanishing point and added that converging line, very light. Okay, so I did that with each of these. Very light. And I did that with each of the squares below. I just lined my ruler up with the vertex to create the converging line that would be invisible behind, right? And I know where this vertex for the back edge is located. So all I did was line my ruler up with that point, and this ruler has a gauge. So I'm lining the gauge up parallel with the front facing edge, and I'm drawing that back edge down. And where those lines converge, I'm lining my ruler up with that point and the gauge of this clear ruler up with the bottom edge of the cube, and you see how the bottom right edge vertex lines up with the bottom left vertex, and erasing my lines. Okay. And I just did the same thing for each of these cubes. If you use 1-point perspective and you start off with a square front-facing edge when you're drawing cubes, then when you draw these vertical lines down to represent the back edge, they will neatly and predictably line up with the vertex on the left. Okay. If you don't draw using the one vanishing point, if sometimes students hit here, 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 and don't pay attention and hit the converging line right on the vanishing point. If you don't hit right on the vanishing point when you're drawing your converging lines, these points and lines will not line up as neatly as I've shown you. Also, if you're starting off with a square that's not square and you're intending to get a cube, you won't get a cube. If you're starting off with a parallelogram, if you're starting off with something like this, you'll get a different result. The rules still apply, you just get a different shape.